Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read Lead Success. I am dealing with the subject Network Analysis and Control Systems. We have already done with the module 1. In module 2, two-port networks is already done. Now in Laplace transform, we are going to learn the topics which are there. Laplace transform. There are two topics in Laplace transform, that is Laplace transformation and basic theorems of Laplace transform. Laplace transform. What is Laplace transform? We will see first. Defined for general function f of t. F of s, which is mentioned here, no? This is how we write Laplace transform. That is capital letter. If it is of the capital form, then it is a Laplace transform. If it is a small form, it is the function where we need to find the Laplace transform. Here f of s is equals to integral minus infinity to infinity e power minus st f of t into dt. What Laplace transform does? It will convert the time domain function f of t into the corresponding frequency domain function. So f of s, the capital F of s is the frequency domain, whereas small f of t is what? Time domain function. We are converting the respective time domain function, that is in terms of f of t, to f of s, frequency domain representation. So f of s is called the Laplace transform of f of t and is denoted by f of s, the Laplace transform of f of t. Laplace transform of f of t is nothing but this formula. Okay, where the notation L is read as Laplace transform of. It is called Laplace transform of f of t. The condition for the Laplace transform to exist is, if you see, minus infinity to infinity f of t e power minus st dt should be less than infinity. For some finite sigma to sigma is the real part of s, then function f of t and f of s constitute a Laplace transform pair. There should be a finite values. Okay. Likewise, in inverse Laplace transform also we can convert. That is, initially for Laplace transform, what we did? Time domain to frequency domain we have converted. Okay. But in terms of inverse Laplace transform, we are going to convert frequency domain, that is capital F to small f, or f of t, means the frequency domain function to time domain function f of t. We are going to convert. For that, what is the formula given? Nothing but f of t is equals to Laplace inverse. We need to write Laplace inverse. F of s is Laplace transform of f of t, means if this L goes this side, so f of t will be Laplace inverse of f of s. So that is equals to 1 by 2 pi j integral sigma minus j infinity plus sigma plus j infinity f of s e power plus st ds. This plus should be there. See, remember this, here it is minus, this is here plus. Okay. So in this way we need to write the formulas for Laplace transform. Using these formulas only we are going to find the Laplace inverse or Laplace transform, where L inverse is read as inverse Laplace transform of this L inverse. Okay, it is from here. If you see, here it is just the minus infinity to infinity, but here complex numbers are also, like complex values are considered. Okay. So these formulas you need to remember. There are some things which are there in textbook which is not required. This is what is the main Laplace transform equation and inverse Laplace transform equation. Those two formulas we need to remember for solving the problems. Laplace transform of a simple time functions. We have some Laplace transform of the simple time functions, like unit step function. Unit step function is nothing but, it is in the form of step. If you see in the diagram, unit step, it is in this form. Okay. Here magnitude will take initial as u1, u of t is the y-axis, and t with respect to infinity, till infinity we are going to write unit step function. They have asked for the Laplace transform of the unit step, how to find? We know the formula as f of s equals to minus infinity to infinity e power minus st f of t into dt. So here f of t is what? U of t. That is nothing but a time domain function. So we are converting from time domain to frequency domain. How to convert? Put in the f of t as u of t, then e power minus st u of t. You know that uni of t is nothing but having the unity function. So you can substitute u of t as 1. So e power minus st integration is e power minus st by minus s. So with respect to what? 0 to infinity. Why we have taken 0 to infinity? Because we are taking u of t as 1. So we are converting into 0 to infinity. Why? Because see, the unit step starts from 0 to infinity. So 0 to infinity means we are considering that respective function in the integration, that interval. 0 to infinity is 1. So we are substituting u of t as 1 and converting this infinity to infinity as 0 to infinity. So you will get 0 to infinity as the interval of the integration. If you see here, e power minus infinity minus e power minus 0 by minus s. You know that e power 0 is 1, e power minus infinity is 0 and e power minus 0 is 1. Minus 1 by minus s is 1 by s. So Laplace transform of u of t is equals to 1 by s. When time t is equals to, sorry, it is just for unit step function. Till here it is unit step function. Now we have unit impulse function. Unit impulse function is delta of t minus t naught, or we can write delta of t also. Delta of t naught is nothing but shift. How much shift? T minus t naught. So if you see here, the delta function is in this form. Only at the point of 0 there is a magnitude as 1. T is equals to 0. That is nothing but impulse function. Impulse function can be anywhere, here or here, somewhere like this, but only at one position. But we consider initially as in the 0th position as the impulse function. So same formula you are going to write. In the place of f of t, you will substitute delta of t. Delta of t, if you substitute, okay, in the place of delta of t, you can substitute it as f of s is equals to 0 to infinity e power minus st into t into dt. When time is at t is 0. You know that there is a time t is 0. So Laplace transform delta of t is equals to 0 to infinity delta of t dt. Delta of t dt is equals to 1. Okay. So the Laplace transform of delta of t is 1. Laplace transform of simple time function. Other simple time functions, we have seen unit step, delta function. Now exponential function, e power minus alpha t or e power alpha t. Alpha can be any value. Okay. E power, first you will see e power minus alpha t. Minus alpha t is nothing but exponentially decreasing function. When if it is increasing, plus it will be. If it is minus e power minus 1, it is decreasing. Okay. F of s is equals to same formula. In the place of f of t, which one you need to convert? E power minus alpha t has to be converted into frequency domain. So e power minus alpha t, if you substitute here, you can see t is common, minus t is common. If you take that, e power minus into s plus alpha t will come. By integrating it, e power minus e power minus s plus alpha t by minus s plus alpha. It is with respect to 0 to infinity. Why? Because we are considering from the point of 0 only. So 0 to infinity we are going to take. So e power minus infinity minus e power 0, you will get as 1 by s plus alpha. Okay. So how you can remember? Easy way to remember Laplace transform of e power minus alpha t is that whenever it is minus, you will get as 1 by s plus alpha. In the same manner, if you do for e power plus alpha t, you will get 1 by s minus alpha. Means if it is e power alpha t, the Laplace transform is 1 by minus alpha. If it here it is positive, you will get in Laplace transform as negative. E power minus alpha t is 1 by s plus alpha. You can remember in this way, Laplace transform. Okay. Next. Sine and cosine function. sine and cosine function. Here f of t is equal to sine omega t, f of t is equal to cos omega t. Okay, we will consider with respect to omega t. So Laplace transform of f of t is equals to Laplace transform of sine omega t. Laplace transform of sine omega t. We know that sine omega t means what? We can write sine theta. If you know this formula, sine theta we can write as e power theta plus, e power theta minus e power minus theta by 2j. We can write sine theta in this form. Whereas cos theta, how you can write? Same, e power theta plus e power minus theta by just 2 for cos theta. For cos theta. Sin theta is what? E power theta minus e power minus theta by 2j. Cos theta is what? E power theta plus e power minus theta by 2. So we can write in this form. After writing, we can apply the Laplace transform. You know that 1 by 2j you can make it as, you can take out and take Laplace transform from only this. When you apply Laplace transform, you know that e power theta, if this j omega you can consider as alpha. So, j omega we can consider as alpha. So, e power j omega t. So, e power exponential of exponential of alpha t of j omega t is nothing but, if it is plus, then is 1 by s minus alpha. So, 1 by s minus j omega. Minus j omega t means 1 by s plus j omega. If you substitute and take LCM, you will get omega by s square plus omega square. Okay, for sin omega, it is omega by s square plus omega square as sin omega t. Here, you will get j square. Here, j square in terms of complex functions, I square or j square is nothing but minus 1. You need to know this. In maths, you will learn this. Cos omega t. Cos omega t is nothing but, you have written e power theta plus e power minus theta by 2. So, Laplace transform of this same 1 by s minus j omega, 1 plus j omega. If you take LCM, you will get as s by s square plus omega square. Just you need to remember that sin omega t is omega by s square plus omega square. Cos omega t is s by s square plus omega square. You need to know these functions because in sums, if Laplace transform directly sin omega, you can directly write that s by s square plus omega square. So, these simple time functions, you need to remember the Laplace transforms. See, there is a table for simple sum of the important Laplace transform pairs. You know that u of t is 1 by s as we have solved. E power a t is 1 by s minus a, and sin omega t is omega by s square plus omega square. Sin hyperbolic beta t. It is nothing but b by s square minus b square. You will get minus for hyperbola. Then cos omega t is s by s square plus omega square, whereas cos hyperbolic beta t is s by s square minus b square. Okay, then e power minus alpha t or a t, f of t is f of s plus a. Okay, you need to remember this also, f of s plus a. F of s plus a is nothing but what? You will get 1 by s plus a. Okay, then t power n is what? N by s power n plus 1. Okay, n negation, sorry, it is not negation, n factorial by s power n plus 1. N factorial by s power n plus 1. T of n. If it is t of n, then if you take Laplace transform for this, you will get as n factorial by s power n plus 1. For example, if it is t square, you think. If it is t square, 2 by s power 2 into 1 by s power 2 plus 1, 3. If it is 3 factorial, then 3 into 2 into 1 by s power 3 plus 1, 4. So, 6 by s power 4. Okay. Like that, you need to remember this Laplace transform of simple functions. Okay. There are some other Laplace transform also, but which are required according to the textbook. I am explaining. sums. Compute the Laplace transform of function f of t, 2 of u of t minus 3. Here f of t is given as what? 2 of u of t minus 3. But till you know, Laplace transform of u of t is what? 1 by s. But you don't know the Laplace transform of u of t minus 3, no? Am I right? You don't know that. So, to do that, what we need to do? First we need to write in this form. 2 u of t minus 3. Okay. You need to write so that you can easily substitute. Or you can just take the u of t minus 3 also. Just u of t minus 3 also you can consider, as you have already mentioned. Why? Because you are considering here 2. Here you need to consider just u of t minus 3. If you consider what? U of t minus, first you initially write u of t. U of t, you know that from 0 to infinity we will write. Okay. After writing from 0 to infinity, what we need to do? Shifting is happening. U of t minus 3. Shift is happening. Like with the minus 3. You need to remember one thing is, if it is u of t minus 3, then it will be right shift. If it is u of t plus 3, it is left shift. Another easy method is, if you see t minus 3 is equals to 0 if you consider. T is equals to what? 3. Means t shifting 3 times. If it is t plus 3. So t is equals to 0, t is equals to minus 3. So it is shifting minus 3 means left side. So accordingly, if using this, u of t minus 3 means what? T is equals to 3. So 3 times shift right side. So shifting right, what you will get from 0, 1, 2, 3. From 3, this will go till infinity. Now what we need to do? Now we have done with the function what they have given, u of t minus 3. So you can remove this u of t minus 3 in the formula. Why? Because you have already written u of t minus 3. Okay, that is nothing but, why we need, how to remove also I tell. See, if it is u of t minus 3, you have already took this u of t minus 3. The u of t minus 3 is from which position? 3. 3 to infinity. Initially you are considered from infinity to infinity, so you have took the function. To remove this, we are substituting u of t minus 3 from the integral 3 to infinity. Okay, 3 to infinity. E power I, because the function is from 3 to infinity for u of t minus 3. So e power minus st 2 into dt. So f of s is equals to 2 into this e power minus st, you will take the integral e power minus st by minus s 3 to infinity. Then e power minus infinity, upper limit minus e power lower limit minus 3s. So you will get as 2 into e power minus 3s by s. Okay, it is so simple. F of t is equals to minus 6 e power minus 2t u of t plus 3 minus u of t minus 2. Find the two-sided f of s and one-sided f of s. We will see when you need to know two-sided and one-sided. How to do that is, first you write off the function. It is minus 6 into 2 e power minus 2t u of t plus 3 minus u of t. What I will do is, I will separately do this function using the graph u of t plus 3 minus u of t minus 3. So that you can remove that part and put that in the integral. So if you see, initially u of t is what? You will write in this form, 0 to infinity u of t. Right, am I right? But you want here u of t plus 3. As it is u of t plus 3, as I told, t is equals to minus 3 it will become. So we should shift left side, 1, 2, 3. So from minus 3 to infinity you are going to mark the u of t plus 3. Then u of t minus 2 you will write u of t minus 2. Means you need to shift right side, u of t minus 2 means 1, 0, 1, 2. So the u of t function only you need to shift to u of t minus 2. Not this u of t plus 3. Okay, u of t function. Why? Because u of t function, the original u of t function is shifting by 2. So 0, 1, 2. From 2 the infinity. So you need to subtract this by this. Why? Because it is minus symbol is given in the question. When you minus it, see here, this by minus this. What you'll get? The same function. This part by this part, the same you will get. But here if you see this part and this part are same. So minus this and this after 2. Minus this and this will become 0. So there is no, after the 2 function, after the 2 value, there is no unit step. Are you getting? So after this, after writing this, what you will do? You will write the formula for the Laplace transform. Then you will put minus 6 e power minus 2t in the e power minus ht in the place of u of t plus 3 minus u of t. Final function what you got in terms of intervals minus 3 to 2. So you will put minus 3 to 2. So you can remove this u of t plus 3 minus u of t minus 2 because you are changing the intervals. So minus 6 into e power minus, here t minus t is common, 2 plus s into t by minus 2 plus s, minus of 2 plus s, minus 3 to 2 is interval. If you substitute the intervals by taking the integration, you will get as 6 into e power minus 4 minus 2s minus 6 plus minus e power 6 plus 3s by 2 by 2 plus s. This is two-sided f of s. If you want only one-sided f of s, what we need to do? One-sided f of s means positive side f of s we need to take. That is this right side. So the interval is what? From 0 to 2. So you will take the only interval 0 to 2 and follow the same procedure by doing the integration. Then you will get 6 into e power minus 4 minus 2s minus 1 by 2 plus s. Determine v of t if v of s equals. Till now we have seen Laplace transform questions. Now we will see inverse Laplace. Inverse Laplace means what? They are asking for time domain function from the frequency domain. If v of s equals to 10 by s, because if you see it's in terms of yes, we need to convert into t. That means nothing but time domain. So how to do the inverse Laplace transform? We will check. Here without formula, if there are simple questions without formula only you can do. For example, see v of s is nothing but 10. You want Laplace inverse of v of s, that is equals to v of t, right? So Laplace inverse of what? V of s 10, that is equals to 10 Laplace inverse of 1. 10 you take it out, Laplace inverse of 1 is remaining. So Laplace inverse of 1 is what? Delta of t. You know that delta of t is the delta of t Laplace transform is 1. So 1 is nothing but what? Delta of t, no? See, you know Laplace transform of delta of, Laplace transform of delta of t as 1, you know. So inverse Laplace transform of 1, what it will becomes? Delta of t, no? Ulta of just the inverse. If you know the formula, you can do inverse. Laplace inverse of 1 is delta of t. So v of t is equal to 10 delta of t. Substitute this as Laplace inverse of 1. Then 10 by s if you see. Laplace inverse of v of s, that is equals to v of t. So Laplace inverse of 10 by s, that is equals to v of t. V of t is equals to 10 if you take outside, Laplace inverse of 1 by s. 1 by s Laplace inverse means, see, you know this Laplace transform of u of t is what? As 1 by s. So Laplace inverse of 1 by s will become u of t. Just if you know Laplace transform, just ulta of the, if that formula if you see here 1 by s means you can convert into u of t. Just Laplace inverse. Then v of s equals to what you have given, 10 by s of s plus 10 is equals to, you can write in this form, see, 1 by s minus 1 by s plus 10. If you take LCM, again you will get the same equation. See, s plus 10 minus s cancel, so again you will get 10 by s into s plus 10. In this form if you write, then Laplace inverse of v of s is equals to v of t. So Laplace inverse of what? 1 by s minus 1 by s plus 10. The Laplace inverse of 1 by s is what? U of t. And Laplace inverse of 1 by s plus 10 is what? You know Laplace inverse of e power minus alpha t is what? 1 by s plus a. So you can write e power minus 10t u of t. You can write u of t. Why? Because for any function you can write this as u of t power minus alpha t u of t. You can write in this way. There is no problem. U of t function, as it is a unit step, just one unit step, you need to mention actually e power minus 10t u of t. You need to mention. Don't get confused. You need to mention e power minus 10t u of t. Then v of s is equals to 10s by s plus 10. So Laplace inverse of v of s is equals to Laplace inverse of 10s by s plus 10. If you see here, 10 if you take out, s by s plus 10. If you see 1 minus 10 by s plus 10, if you do, though again if you take LCM, s plus 10 minus 10, 10, 10 cancel, s by s plus 10 only you will get. So if you see here, Laplace inverse of 1 is what? Delta t. And Laplace inverse of 10 by s plus 10. If you see, it is in the form of 10 into nothing but 1 by s plus 10, nothing but e power minus 10t, e power minus alpha t form it is. So e power minus 10t, 10 into 10 it will become as what? 100 e power minus 10t u of t you can write. Understanding? This 10 should be multiplied with this, and again 10 is there inside. So 10 into 10 e power minus 1 by s plus a is e power minus alpha t. For this you should know the formulas. You need to keep quickly, like Laplace transform of e power alpha t 1 by s minus a, Laplace transform of minus alpha t 1 by s plus a, Laplace transform of u of t 1 by s, Laplace transform of delta of t 1, Laplace transform of sin omega t, omega by s square plus omega square. Like that you need to practice the formula, so you can easily do the formulas by just substituting. Yes, no? So just understand the formulas, how to do Laplace transform, so you can easily do this sums. Determine v of s. See again Laplace, this may v of s. We need to find the Laplace transform. V of s, if v of t equals to 4 delta t minus 3 u of t. See, same Laplace transform formula is infinity to infinity e power minus st v of t dt. V of t is 4 delta t minus 3 u of t dt. So 4 if you take outside, not 4 outside, we need to multiply e power minus st inside for the both and do integration separately for both. Then you will get, you know that delta of t, nothing, why delta of t is what? 1. So when t is equals to 0, when t is equals to 0, delta of t we take at the time 0. So t will become 0. So e power 0 will become 1 and delta of t is 1. So only 4 we are left with. So 4 into 1 and minus delta infinity to infinity 3 into e power minus st u of t. You know that e power 3 into e power minus st. If you see that u of t you can remove, why? Because it is a unit step function. Then 4 minus 3 into e power minus st by minus s, 0 to infinity. If you substitute the integral values, you will get 4 minus 3 by s, nothing but 4s minus 3 by s. See, don't get confused. Here u of t, why we are removing? Because integral it is here from minus infinity to infinity. But now we are changing to 0 to infinity. Why? Because u of t will start from 0 to infinity, unit step function. As we are changing from the integral, the u of t can be removed. Why? Because we are including the integral. Okay. Then v of t is, next question is 4 delta of t minus 2 minus 3 t u of t. If you, it is the same procedure. If you see here, but here delta of t minus 2 is there. If you here what we should do, we need to substitute t minus 2 is equal to 0. So t will become, at t equals to 2 there is a delta function. So the place of t you need to write 2. Okay. So Laplace transform of this will become e power 4 into e power minus 2s. Okay. Minus 3 into, if you see this, it is in the form of t into u of t e power minus st. So t into e power minus st formula is what, you know, 1 by, nothing but 1 by s power n plus 1. So 1 by s square. Okay, t power n e power minus st is nothing but n by s power n plus 1. So we will write 3 into 1 by s square. So another example, Laplace inverse of s plus 4 by 2s square plus 5s plus 3. How to do this? S plus 4 by 2s square plus 5s plus 3. Laplace inverse of f of s equals to f of t. F of t is equals to Laplace inverse of, we'll put the f of s value. If you know, see, first what you should do, you need to find the factors form. This s plus 4 is nothing but what? You can write in terms of 2s plus 3 into s plus 1, right? So if you write in this form, in maths, if you know, there is a partial fraction method where s plus 4 by 2 s plus 3 into s plus 1, we can divide into a and b, a by 2s plus 3 plus b by s plus 1. If you see these two are same, you can by after taking LCM with a and b, 2s plus 3 plus s plus 1 LCM and multiplying with a and b, you can cancel these both. You will get s plus 4 is equals to as plus a plus 2bs plus 3b. If you see these terms, you need to equate. So a plus 2b is equals to 1. Why? Because s terms separately we need to equate. So a plus 2b, that is equals to 1 is the one equation. Another one is what? A plus 3b is equals to 4. Another equation. After writing the equation using the cancellation method, if you see if you need to convert the plus to minus, as all are in the form of pluses only, so minus minus minus, to cancel it, a and a will be cancelled, then you will get minus b minus 3. So b will be 3 and substitute b value, then you will get a equals to minus 5. Substituting these values in the partial fraction, what we have done, you will get minus 5 by 2s plus 3 plus 3 by s plus 1. Now we need to apply Laplace inverse. So make it easy, we are doing this. Okay, directly you can't apply Laplace inverse, so you need to know partial fractions and all of maths. So Laplace inverse of minus 5 by 2s plus 3 by s plus 1, you know that if you take here 2 common, what happens? S plus 3 by 2 plus 3 by s plus 1. So minus 5 by 2 will get taken out, so 1 by s plus 3 by 2 will become e power minus 3 by 2 Laplace transform. Then 3 by s plus 1, 3 into 1 by s plus e means nothing but e power minus 80. So e power a is 1 here, so e power minus t. So that is equals to, if you take 1 by 2 common in the both, then you will get minus 5 into e power minus 3 by 2t. If as you are taking minus 2 common, you need to multiply 2 inside, 6 e power minus t. If you can leave the equation final answer here also, or you can take 1 by 2 common also, it is your wish. Calculate the inverse transform of 2 into s plus 2 by s. If you see here, the method is same. Laplace inverse of f of s is nothing but f of t. You want frequency domain to time domain. F of t is equals to Laplace inverse of 2s plus 4 s Laplace inverse. Laplace inverse of 2 plus 4 by s. You can write 2s plus 4 by s by 2 plus 4 by s. Then what happens? Sorry, 2 plus 4 by s if you write also. If you take LCM again, 2s plus 4 by s you will get. Again if you take common of this, then you will get 2 into s plus 2 by s only. Right? We are just making it easy. 2 plus 4 by s. So Laplace inverse of 2 will be what? Laplace inverse of 1 is delta of t. Laplace inverse of 4 by s is nothing but 4 if you take out. Laplace inverse of 1 by s is u of t. Okay, simple. If you know the Laplace transform, it is very easy. Then given the function q of s is equals to 11s plus 30 by s square plus 3s. Find q of t. So if they want the Laplace inverse of the function q of s. So q of s is equals to 11s plus 30 by s square plus 3s. So q of t is equals to Laplace inverse of q of s. Laplace inverse is 11s plus 30 by s into s plus 3. Again here we need to consider the Laplace partial fraction. Why? Because it is not easily, we can't easily make common or do something and do Laplace transform. So we need to take partial fraction here again. So if you see a by s and b by s plus 3. Why? Because two separate factors are happening here. So you can do partial fraction. 11s plus, and again these two will be cancelled after taking LCM. 11s plus a into s plus 3 plus bs. If you see a and the s terms are a and b, a plus b is equals to 11 and 3a will be equals to 30. So a will be 10, b will be 1. If you substitute them, you will get as Laplace inverse of 10 by s plus 1 by s plus 3. U of t is equals to 1 by s Laplace inverse is u of t. Laplace inverse of 1 by s plus 3 is nothing but Laplace inverse of 1 by s plus a, nothing but e power minus alpha t, e power minus 3t you can write into u of t. If you take u of t common, you can nothing but 10 plus e power minus 3t into u of t, you will get the value. So these are the practice questions which are solved similar questions in the video. So please try them out. If you have any doubts, you can ask me. I will help you out. If you have any doubts, you can comment me. By this topic, Laplace transform is done. I'm stopping the video here. With the basic theorems, I'll do another video and upload. So Laplace transformation is done now. Thank you from Sri Sai Tech Edu YouTube channel. Read, lead, success. Keep reading.